Well, welcome back, Mr. Colazar's class. What we're looking at now is continuing with section 6.3 in the notes, looking at noble gas shortcuts. Now, before we start there, just to go backtrack just a little bit, to go back to our periodic table. Now, remembering from before that our first two blocks on the periodic table, or excuse me, our first two columns on the periodic table is our S block. So we had our S1s, our 1S1, 2S1, 3S1, 4S1, and then our S2 over on the opposite side. Our P block was groups 13 through 18, and then our D block, groups 3 through 12, and our F block was down at the bottom, and the F block actually moves up and starts up here, and then the second one down here. Now, F block with F was N minus 2, and the D block was D was N minus 1, where N was our energy level, which is the period. So energy level 1, 2, 3, 4, 5, 6, 7. So as we went across the table, if we were to choose any of our elements, example could be if we were to pick silicon, and copper will be a couple of them that we're going to look at, and then eventually astatine, just as some warm-up. Those elements as we're going silicon element 14, so 14 electrons total for element. Would have come up with the configuration as we went through 1s2, 2s2, 2p6, 3s2, 3p2 to give us our 14 total electrons. Copper was a little bit different in the fact that it took one of the electrons from the 4s, and instead of being 4s2, 3d9, it made it all the way and took one of the electrons to give to the d10 to be a 4s2. Now, astatine, element 85 on the periodic table. Entirely too many electrons for us to generally write out normally. Astatine would look something like 1s2, 2s2, 2p6, s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d6, lost my place, 5s2, 4d10, 5p6, 6s2, 4f14, 5d10, 6p5. To give us all 85 electrons. So what we're going to look at today is how we can make a shortcut out of this. So in our notes, what we're going to look at is two electron configurations. We have neon and we have magnesium listed here. So neon element 10, magnesium is element 12. But what we can notice between the two is that the beginning parts of both are very similar. So as we're going, what we're going to see is the beginning part same between the two. And what we're going to do is we're going to substitute for magnesium this beginning portion. And in the end, we're going to remove that beginning heading, and we're going to add neon in brackets. That's going to be the key part. That's going to symbolize that 1s2, 2s2, 2p6 is going to be symbolized by that neon in brackets. So a couple rules for us to follow. Let's make sure we get all three of these rules down. You'll need them. So hit pause and then hit unpause after you've gotten all three. Alright, so the first part is we're going to find the element of interest on the periodic table, whatever element we're looking to choose. Secondly, we're going to use the noble gas from the period above. Then we're going to use the next period and the blocks to write out the electron configuration. So our first element we're going to choose silicon, and then we're going to look at acetine, and then copper also. So if we were to look back on the periodic table, if it'll let me get there, silicon, the element right up above, as we're moving over, neon would be in the row above that noble gas. So we move up one row and over to the noble gas. So for silicon, neon would be the element that we're going to look at. And then after that, then we just write out the entire row that follows. So our 3, that would be our 3s2, 3p1, 3p2. So as we're going, silicon, we put neon in brackets. That represents all that information beforehand. And 3s2, 3p2. Now for acetine, acetine as we're going was a much further down on the periodic table, and it looks, as we're going, element 85 again. Now the element right up above and over noble gas would be xenon. So xenon is what we're going to start with, and then as we're traveling, we start in period 6 and we've got to go all the way across. When we go across, we go through our 6s period. However, this is where a key part is. We drop down into our 6, 7, into the 6f. But instead 6 n minus 2 is 4. So we move through the 4f all through all 14 of the f elements. And then we're back up into the 5d, n minus 1. So this will be our 5d, moving through all 10 of the d elements. And then back to the 6p. 1, 2, 3, 4, 5. So 6p5. So as we're looking at doing that, for acetine, we said the element was xenon in brackets, and then we're going to read straight across the rest of that row. 6s2, then we go into the f orbital, n minus 2, so 4f, filled up with its 14 outer electrons, 5d10, and then finally 6p5. So much shorter now than it was before. That'll be about as difficult as they could ever get, is acetine right there. From there, copper. Remember, copper had that one change to be made. With copper, we are looking at an element that is in our 11th group, and it's going to want to be that wild card that's going to steal an electron. So copper, as we're going, noble gas one row above carbon or copper is argon. So argon is going to represent those first 18 electrons. 1s2, 2s2, 2p6, 3s2, 3p6. All that is represented by the argon. And then argon, copper, 4s1, 3d10, with that change to be made there. So as we're going noble gas shortcut, shorthand way to write our electron configurations out. Last up, just a little reminder from last section, our Lewis structures. Remember, Lewis structures just show the outermost electrons. So outermost electrons for neon, 3s2, 3p2, both from the third energy level. So 1, 2, 3, 4 outer electrons. For silicon, we would show silicon Si with the 1, 2 paired, 3 and 4 outer electrons. So as we're going, remember, our first 2 electrons are paired, and then single, 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 paired, paired, paired. That's not our notes, but that's just a reminder from last chapter as we'll see those as we're going forward, only showing those valence or outer electrons. So you'll be seeing that coming up on our next couple of problems on worksheet 6-2. So, hydrogen, 1 outer electron, carbon, 4 outer electrons, calcium, 2 outer electrons, and bromine with 7 outer electrons shown by the total number in the highest energy level. Calcium 2 in the second, or in the fourth energy level, bromine 2 and 5 both in that fourth energy level are the highest ones there. All right, we'll let you get to work on the problems coming up.